Hello everyone, it's me again. This is the second part of the lecture on lines and planes. Here we will define EV&TS, analyze a plane in 3D space, and learn how to show the EV&TS of plane using given views. A plane is in edge view if it appears as a line in that view. EVs can be obtained by using a projection plane that is perpendicular to the given plane. Take note that if a plane is in EV, some lines lying along the plane are in point view. A plane is in true size if the actual size and shape of the plane is shown. TS can be obtained by drawing a projection plane that is parallel to the given plane. Take note that if a plane is in TS, lines lying on the plane are in TL. Let's now check how a plane looks in a 3D space. In this example, we have a plane in the X, Y, and Z axis. This plane is already enclosed by a cube which we will use in our projections. If we project the plane in the frontal reference plane, we will obtain a line. This line is what we call the edge view of the plane. Take note of the relationship of the projection plane and the given plane. The projection plane is perpendicular to the given plane. Also, observe that these lines lying on the plane perpendicular to the projection plane will appear as point view in the projection plane. Take note of this as we will be using this in drawing EVs in orthographic drawing. Again, lines lying on the given plane appear as point view in the projection plane. If we use a projection plane parallel to the given plane, the exact shape and measurement of the given plane will be captured by the projection plane. This projection gives us the true shape and true size of the plane. Also, observe that the projection plane that will give us the TS, this projection plane, is parallel to the edge view of the plane. So this projection plane is parallel to the edge view of the plane. Take note of this as we will be using this in drawing planes in orthographic drawing. I will now teach you how to draw the EV and TS of planes in orthographic drawing. Given the top and front view of plane ABC, let us try to draw its edge view. Again, an edge view is made up of point views of lines lying along the plane. This means that for us to show the edge view of a plane, we have to get the PV of a line lying along the plane. In this example, we already have a line AB in TL. Recall that a TL is needed in order to draw the PV of a line. If we draw a line perpendicular to the TL and project all points, we will get the point view of line AB, and at the same time, we will get the edge view of the plane. Take note that EVs must always be labeled. If a plane is already labeled EV, labels for lines such as TL and PV are no longer necessary in that view. What if there is no TL in any of the views? We are not limited by the sides of the plane. Again, as long as you show the PV of any line lying along the plane, you can get the edge view of the plane. Here, we can make an imaginary line AX. Since we want to immediately get the true length of this line, we have to make it parallel to the reference plane. In this example, line AX is parallel to this reference plane. Next, we have to project the imaginary line. Since we used A as one of the endpoints, we only have to project point X in the other reference plane. Line AX will then appear as TL in the top view. We can then add a reference plane perpendicular to the TL of line AX, then project all points, and we now have AX in point view, and at the same time, plane ABC is in edge view. Again, label the plane as EV. Now it's time for TS. If you are asked to determine the dimensions of the plane, you have to look for its true size. the view showing the true size gives the measurement of the plane. Before you can draw the TS, you must first have a view showing the edge view of the plane. Here is the EV we obtained earlier. As I mentioned earlier, to draw the TS, the reference plane must be parallel to the EV. Here, we draw a reference plane parallel to the edge view of plane ABC. We then project all points, and the reference plane will give us the true size of plane ABC. If you draw a reference plane adjacent to the view showing the TS of the plane, the projected plane will be in EV that is parallel to the reference plane. In our example, if we add this reference plane adjacent to this true shape, the resulting view will give an edge view parallel to that reference plane. This ends our lecture on lines and planes. In summary, you learned how to project lines and planes, how to draw the TL and PV of a line, and how to draw the EV and TS of a plane. Thank you. Do your best in answering the assessment tools.